Welcome, I'm Elliotte Harold. This is Code 1, and I'm going to talk about exceptions, which is an unusual topic to choose for something like this. You heard the keynotes. Vincott was talking about lambdas and closures and continuations and stuff that might be 5 years down the road. Next door, somebody is talking about Java 12. I'm not sure when that's out, but you know, the new stuff. I'm talking about Java 1.0. I'm going back to about 1995 because some of the message and some of the stuff I'm talking about today still hasn't gotten out into the community for reasons I'll discuss. And in my opinion, a lot of this stuff is really important, really helps to make robust, maintainable code that responds properly to unexpected conditions, and will do a lot more for making your code robust than lambdas or closures or generics or a lot of other things that we've added to the language for the last 20 years. Now, before I get started, usual disclaimer, this is my personal opinion, does not represent the opinion of Oracle, my employer, SIFWA, the National Football League, or anybody else except me. I don't think any of them actually care. The lawyers at my employer, like to review my presentations, and they took one look at this and said, it's too technical, we don't care. So where do I come from? I'm currently I'm tech lead for Google's Cloud Tools for Eclipse project. I've also developed a number of open source projects over the years, including the ZOM API for parsing XML. I'm the current maintainer of the Jackson library for operating with XPath expressions on various forms of XML and non-XML tree structures. I've written a few books here and there. I also contributed heavily to JDOM back in the day, circa 2001, 2002. I regret to say I made a lot of mistakes in my contributions to JDOM, particularly around exception handling. One of the things and as a result, I corrected a lot of those in ZOM, but I think JDOM still, one at least, maybe not JDOM 2, has some issues that are directly my fault. And I apologize for that. I'm going to hope you're not going to make the same mistakes I made with those. Now, I'm going to assume everyone in this audience is a Java developer, is reasonably experienced with Java. You know what an exception is. You know what a runtime exception is. You know when you need to write a catch block and how to use a throws clause in a method signature. I'm not going to go over any of this stuff. This is not Java 101. But I am going to talk a lot about why you do something one way versus the other, and when you use which kinds of exceptions, and how best to organize your code so that it works with the language and the language features and not against it. Now I'm going to begin with a quote. This is from an anonymous contributor on Stack Overflow, or maybe somebody who deleted their account, I don't know. Did Java designers really invent anything? As far as I know, they simply brought together a bunch of ideas that had been sloshing around for quite some time prior to the language's inception. Certainly that's true of a lot of Java. A lot of it comes from C and C++, and even more from Objective-C, as well as some other languages. But I will say there is one thing that is in the Java programming language to this day. One of the first features went in about 1.0 alpha 3, if I recall, in 1995, that has not been seen in any language before or since. And that is checked exceptions. And several barrels of ink, and I don't know how many electrons have been spilled over making sense of checked exceptions, when you use them, how you use them, and whether they make sense at all. You will certainly see a lot of languages that have come since, notably C#, looked at exceptions in Java and said, we don't need checked exceptions. They're not worthwhile. They just confuse people. There's nothing there. They're not a good idea. I'm going to hope to convince you otherwise, even if I haven't convinced the people who designed C#. Now, checked exception, I think most of you probably already know this, can be statically checked at compile time. That's really critical. You know what code might and might not throw a checked exception under which circumstance. It's not just going to pop up and surprise you. The compiler recognizes this. And compile time errors are generally preferable to runtime errors. The sooner we find a bug, the sooner we find a problem in the code, the easier and the cheaper it is to fix. The further we find, worst case scenario, it's in some binary code that's been embedded into some device and that has been shipped to 10 million customers and can't be updated. And then you've got everything in between. The earlier in the development cycle you find the bugs, the better. Checked exceptions are designed to surface bugs and error conditions sooner rather than later. Furthermore, because programmers sometimes get lazy, checked exceptions are designed to require error handlers so that programmers must prepare for a checked exception. They must be explicitly accounted for in code with either a catch block or a throws clause. You can't just ignore them. That's why they're a little annoying, because we can't forget about them. We can't just write code. The programmers often feel like they get in our way. Now, I maintain checked exceptions work. You have to go out of your way. You have to have extra effort to ignore them, and that's a good thing. They make code more robust against unexpected conditions like files not found, network socket failures, etc. They make the code more readable, although not everyone believes that, but I think that's because they're writing the code wrong, and I'll show you that in a minute. And they prevent lots of bugs and other problems. But, and this is a huge but now, only if you use them as they were designed to be used. I don't know who added checked exceptions to the languages. I've heard various rumors over the years that they snuck in when somebody else was on vacation. I don't know if this is true or not. I don't know who first came up with the idea. I do know they weren't in Java 1.0 Alpha 1 in 1995. Anyone else remember that version of Java? I think they first came in 1.0 Alpha 3. But this is the big problem. Sun forgot to tell people how to use them. They had a very clear purpose, a very clear design, and it was very rarely, if ever, written down and evangelized. People focused very heavily on just the syntax of catch blocks and throws clauses, and not the semantics of when you need to use these things and when you don't, and when you use a checked exception and when you don't. Now, I think explaining this works best if we divide it up into goals and rules. What are checked exceptions designed to do for you? And then what do they actually do? Some of this was actually explicit circa 1995, and there were a lot of white papers that talked about this, and some of the early, this is why Java is a good language white papers that James Gosling and others wrote and that Sun published at the time. As far as I know, those have all gone to the big 404 in the sky at this point. I looked for them. As of a few years ago, I could still find one of them hidden away on Oracle's website somewhere, but that's no longer there. There's probably some old copies floating around on old hard drives if anyone has one, but some of this has gone away. So some of this is just now in the memory of people who were around 20 years ago. The first goal of Java, and this used to be explicit, although no one says this anymore, is to separate the main code path from the error handling. At the time, in 1995 and the early 90s, when Java was designed, there was a lot of C code running around Sun and other Unix vendors, and it returned error codes. If you tried to open a file and you couldn't open the file, you got back an integer, and you had to figure out what the integer meant. And then you had to write an if block. If return, I forget whether it was equals 0 or not equals 0 was the error condition, but whichever way it went, you'd write that code and then you'd check it. Except most of the time you ignored the error code. And even if you caught the error code, then your program became spaghetti logic of if blocks for error conditions and non-error conditions. It was really hard to follow. It was a mess. Exceptions were designed to prevent that. Number one, by making handling of these conditions mandatory. You couldn't just ignore the return value. And number two, by separating the main path from the error handling. The goal was write a bunch of code that assumes all files can be opened, disks don't fill up, DNS queries return a proper response, network sockets connect, et cetera, et cetera, et cetera. Everything you expect to happen does happen and at the appropriate time. So you write one block of code completely ignoring all possible error conditions. Then you write separate blocks of code that handle the error conditions. This is why try-catch blocks look like they do. And the rule, okay, I don't know why we blanked out up here. I can still see it in front of me. There we go. Is that your try blocks and the amount of code you put in them should be long rather than short. Almost all the code in a method that might throw a checked exception that you want to handle in that method belongs in a try block. So most variables should be scoped to a single try block, if they show up in a try block at all. Obviously, there's lots of code where no checked exceptions may be thrown. You're just doing math and making calculations. You're not opening files or talking to a database or anything like that. This is especially if the constructor that creates the variable, if it's an object variable, not a primitive variable, might throw an exception. And it's triply true in Java 7+. Java 7 made a big improvement in exception handling, the first since I think Java 1.0, when they added try with resources, which made closing files and verifying that and variable scoping a lot stronger than it had been. Before we had to do a lot of if null checks before closing things, and now we usually don't. So this helps a lot. What you don't want to do, and what I see a lot of people even advocating that this is the right way to do it and this is why they hate exceptions, is this. You know, declare a variable, deployment job in this example, but don't initialize it. Then you have a try block to initialize the variable. And then you catch the exception that might be thrown and do whatever you do with it. Here I just print an error and return. Obviously you can do something more obvious. Then you call a couple of other methods. Then you have a second try block that calls a method that might throw an exception. And it catches another exception and handles it. And then you finish. This was not how exceptions were meant to be used. If you are writing code like this, or if you get a code review where there's code like this, push back. Exceptions were explicitly designed back in the Sun in the early 90s to look like this. One big try block, which ignores all error conditions, followed by the catch blocks that handle the individual error conditions. This is a lot cleaner, and it makes for much more maintainable, simpler code. Now, the common objection to this is, what if I have two lines of code that both throw the same exception? How do I, well, usually that doesn't happen. When it does, 9 times out of 10, it's the same kind of error handler anyway. If you really need to distinguish between them, you can embed a catch block, you can create a subclass of the exception that's thrown. There's usually some other clues you can use. But this is what exception handling code was meant to look like. Big block of code, no error handling at all, error handlers later. Now, of course, you don't always have to have error handlers. You know, maybe you choose to declare that your method throws one of these exceptions if you want to handle it higher up the stack. The second goal for exception handling, maybe the first goal, honestly, was to make programmers prepare for environmental problems, because at that point, decades of experience with C and other programming languages had taught us that you cannot rely on developers to check error return values, even if they're supposed to. And furthermore, you cannot write code so that these problems aren't going to happen. You know, the network is out of the control of the developer. When we are writing code, we do not know whether we will be able to make a connection to www.google.com, or maybe the fiber line that connects our building to the rest of the world over the internet, someone dropped a backhoe through it 15 minutes ago. It's nothing you can prepare for, so you have to write an error handler. You have to say, if this I/O error occurs, here's what we want to do about it. The goal is to keep code from blindly executing when the environment is in an undefined or unexpected state. It forces the jump to an error handler. And if you're working in a high security environment, or a critical environment like an airplane, where if something goes wrong, people die, then this is triply critical, because you don't want to miss possible error problems. Another example you can think of is if you're sending a mission to Mars, where it's got to we seem to lose about 1 out of 2 out of 3 of every mission we send to Mars just crashes on the planet because of software errors. That's not also hardware errors. That's not good. So the least we can do is require that when something can go wrong, we've planned for it, and that the compiler can check. That's one of the big purposes of checked exceptions, is to stop programmers from being lazy and ignoring the possible error conditions. Now, this is critical. Checked exceptions are for environmental problems, things that happen outside your own code. I/O is certainly the most common, including network problems. Anything that would involve the time of day, the state of hardware, anything outside your program, that is an environmental issue. You cannot prevent it from your own program, so you have to be ready for when it goes wrong. Notice I say when it goes wrong, not if it goes wrong. It will go wrong eventually. Cloud SDK not installed in the expected directory. That's something that happens a lot in Cloud Tools for Eclipse, so we check for it. By contrast, runtime exceptions indicate bugs in your own code. That could be a null pointer exception, you walked off the end of an array or a list, something like that. It's something that if you had written the code properly would not have happened as a rule. Maybe you forgot to check that a variable that could be null was not null. However it works, that is something that should be fixed in the code. That's why we don't have to write catch blocks for them. You will sometimes hear it be said that catch blocks, it would just be too much trouble if you had to write a try catch for every variable access that could catch a null pointer exception. I agree, it would be way too much trouble. But at the same time, you shouldn't be dereferencing null variables in the first place. If you find a runtime exception in your code, you see in the log files for your servlet or whatever it may be, that null pointer exceptions are showing up, then go back into the code, look at the stack trace, figure where the null variable came from, write the code to handle it, and then publish a new version. That's how runtime exceptions are typically handled. Now, for high security, mission critical systems, that's not good enough. You probably do want some sort of top level exception handler so the null pointer exception in one servlet doesn't bring down your whole web server. But essentially, anytime you do see a runtime exception in production, that means there is a bug in the code and the code should be fixed. And now I have lost, oh, there we go. Wow, that is hard to look at. Can you wiggle the HDMI cable maybe? Okay, now we've, okay, I think I don't want to send anybody into a seizure. It's not my goal. Okay, and I think I need to be, yeah, there we go. Now, what is an environmental problem? As I said, anything that happens outside the control of the program. It can mean external data that comes into the program is malformed in some way. That's what you typically get with XML or JSON. Could be an authorization failure, default character sets, external programs not available, etc. All of these things would typically, anything that isn't bundled into the jar file you actually ship is one way of thinking about it. That's an environmental problem. What is not an environmental problem? Unsupported operations, illegal argument exceptions. Illegal argument exceptions are a weird one. It sometimes depends on, they are runtime exceptions, but it depends on where the value comes from. So there are some boundary cases. There are some edge conditions where it's not always totally clear. If a string comes from the user and it's supposed to be a number but isn't, I mean, obviously that is, if you're the user supposed to type a value into a box that's a number, and it comes in and the string is not a number, it's, SEVEN instead of the digit 7, that would be typically an environmental problem, but it's probably going to show up as an illegal argument exception. So if you're doing that sort of thing, that's where you write a catch block for a runtime exception that you would specifically expect might occur. But the compiler won't force you in that case. On the other hand, if method A passes a string to method B and that string is in the wrong format, that is a bug in the program. So you would typically fix method A rather than putting a catch block in method B for that example. Third goal, move error handling to the method best able to deal with it. Another common anti-pattern in exception handling code saying, oh God, this method throws an exception, so I have to do something. I don't know how to handle that the file wasn't found here, that I can't load my data, that I can't connect to my database. So maybe I can log an error message, or maybe I can throw up a dialog box, but maybe I'm deep inside a library and this isn't a good place to throw up a dialog box. So what do you do about it? Often, nothing. If you can't handle an exception where it is thrown, bubble it up through the call stack. Just if a danger exception is thrown inside method A and method A doesn't know what to do about it, then just declare method A throws danger exception. And whoever calls method A then has to also put in a catch block for danger exception, or declare that they throw it. And it is perfectly okay to let the exception bubble up through 5, 6, 7 layers of the tree until it gets to the point that is best able to handle it. Sometimes when you're doing this, you will find yourself bubbling up through other methods that aren't prepared to handle that specific exception, methods that you may not have written. In that case, you can often convert an exception type. I think this actually went into Java, about Java 1.4, where you can now chain exceptions together so that one exception has a cause of another. Use it. Pass the exception up the tree. If you really get stuck, you can chain an exception into a runtime exception, but then you've broken the whole design of what checked exceptions are for, and you are running the risk that somebody is not going to put a handler in the right place. So I wouldn't try that in library code. But in your own application, if you have to wrap a checked exception into a runtime exception to let it continue up to the point where it will be handled, I can live with it. It's not ideal, but it's better than the alternative. Yeah, that's what I just said. Also, I would say do this for exceptions that can't happen. At least not in, the one that constantly gets me is if you are converting a string that's into bytes using the UTF-8 character encoding, or some other character encoding that is known to exist in the virtual machine by, according to the Java language specification. That's actually going to be, I think, an I/O exception of some kind, char set not found, something like that. And that exception really can't happen unless the virtual machine is broken. What are the odds that the virtual machine is broken? Low, but not zero. I have seen in production exceptions that happen because the virtual machine is broken in some way. Maybe it's not the official Oracle JDK. Maybe it's been hacked a little bit. Maybe somebody has cut out pieces. This happens, but I wouldn't worry about it too much if you know the environment you're working in. There are cases where I will just catch an exception and eat it if I know it really, really isn't possible. But a better option in this case is throw new runtime exception X. So that if the exception that you believe can't happen, if you're wrong and it really can in some circumstance, then you'll get a warning and the runtime exception will either shut down the program or perhaps be caught by a catch block higher up the stack than the application server in the web server that is logging all your exceptions. By the way, if you're doing that, if you have a master catch block up at the top of whatever program you're doing, be it a main method, a servlet engine, etc., and it's logging exceptions, please make sure someone looks at the logs. There's no point to logging exceptions no one's ever going to look at. So, the last thing you want is to discover that, a customer has reported a really nasty bug to you that's going to get you paged on Saturday evening at 7:30 p.m. when you've got tickets to go see Harry Potter. And then realize after you finish debugging it, 15 hours later, that if you'd been looking at the log files, that this bug would have been fixed months ago. Don't ask me if that's a real example. Okay. Actually, let me back up. One other case that may be important. If you are implementing a non-exception savvy interface, this happens a lot with Runnable in particular, it can also happen in Lambdas, then it may be okay to wrap the checked exceptions. That being said, if you're using Lambdas, part of the purpose there is that they are pure functional code, and exceptions are by their nature not functional. They are side effects. They really do not mix well together. I would, for that matter, I/O doesn't mix well together in functional code. So I would not use Lambdas for anything that might throw a checked exception. Just don't. If you're trying to force a method that throws a checked exception into a Lambda, stop, say, okay, maybe this is time to use a for loop. Or maybe this is time to use some other more traditional means of code rather than the newest, funkiest, feature. Okay, the one reason not to use exceptions or not to use checked exceptions, other than arguably Lambdas. This is the one that keeps me awake at night. This is the one where I say, maybe all the people who don't like checked exceptions are really right. If we haven't learned how to use checked exceptions in the last 20 years, if the community is still having trouble with this, and we are. I see things like the Bluetooth API from, well, back in the day it was from Sun. I guess it's now from Oracle. Never got broad adoption. That got exceptions exactly backwards. All their I/O errors are runtime exceptions. If they can't connect to or pair with a Bluetooth device, that's a runtime error in the Java Bluetooth API. Whereas all their programming errors are checked exceptions. I pointed this out to them back in the JSR and I got nowhere. So this is complicated. This is a hard message to get across, so I think it's worth trying to get it across. So I'm not sure I would recommend this to a new language. If Java developers don't get a hold of this, is anybody else likely to? Maybe they are just too complicated. Maybe we should just say runtime exceptions for everything and let the errors fall where they may, and if the programs crash, the programs crash. I don't like that, but sometimes that's where we are anyway. I will say this, if exceptions and the proper choice between checked and runtime exceptions is too hard, there are a bunch of other things that I have to worry about are also equally too hard or too complicated. Lambdas, way more complicated than exceptions, far more difficult to get across. Data binding is a real pain because it's trying to mix between statically typed and not so statically typed systems. That's a really annoying thing that is the source of a lot of both runtime and checked exceptions and a lot of other things. So if exceptions are too complicated, there needs to be less rather than more in the language. That being said, I'm not sure they are. I think there's a lot of room for improvement in how we as Java developers work with exceptions, but I do think it is a solvable problem. The main point is just to get the message out there. Checked exceptions for environmental problems, especially I/O, runtime exceptions for programming bugs. And that's the main message. Get that right, the code works, and life gets really, really simple. Okay, if anyone has thoughts, questions, comments, floor is open. I will say in advance, this is not Jeopardy. If you disagree with me vehemently, you do not have to phrase it in the form of a question. You're welcome to say, you are completely wrong, and here's why. And I am free to disagree with you. Or if you want to ask it as a question, go ahead. Yes?
I'm feeling we're in the solid majority because I've always secretly, but I never would have said it in public. I am a checked exceptions believer. One thing I would disagree with you on, though, is you said that it might be too complicated. I think it might even be more complicated if you take them out of the language.
Right. Well, if you take them out of the language, you do have to write less code, but you need that code you're not writing anyway. So yeah. If you want the robust error handling that you're guaranteed to have, exceptions help you see where you need it.
The exceptions come from the runtime exceptions. You track all the others.
Right. Yes.
You may can actually maybe do something about, meaning you throw it,
Right.
the part catches it, and, I mean, maybe there's nothing can be done, or maybe something can be done.
I'm very glad you asked that. The question is, can you classify exceptions, check versus runtime, according to whether you can handle them or whether you can't handle them? Is that a fair description? Yeah. No. Effective Java sort of tiptoes around that, and I've heard that claim made, but that is not how checked exceptions were designed. That is the difference between exceptions on the one hand, including checked and runtime, and errors, java.lang.errors. Java.lang.error is for out of memory. The heap is full. No such method def found because the class path has the wrong version of some dependency. Something that really truly is unlikely to be able to be handled is an error. And again, by an error, I don't mean a generic error, I mean a specific instance of the java.lang.error class. And yes, you can catch it. Usually you don't want to. With exceptions, with I/O problems, most of the time you don't even know how a file not found should be handled at the point where it is first detected. That is why you created an exception and let it bubble up the chain to the code that does know how to handle that problem. So yes, what you're describing is the distinction between an exception and an error, not between a checked exception and a runtime exception. Okay. Other thoughts, comments, questions? Yes? Have I seen a case where runtime exception is converted into a checked exception? It's uncommon. I don't see it a lot. I suspect I've seen that happen occasionally, but I don't remember a specific example right off the top of my head. There's no reason not to do that. I mean, it certainly can be done. I guess the case where it would make the most sense is, where you want to convert, I don't know, maybe, I can contrive an example where you're trying to invoke a method that you think may not be available, there may not be a dependency on your path, and that would cause that'd be no such method def found error, and you could catch that and convert into an application-specific exception that says there's a configuration problem. But yeah, it doesn't seem to come up a lot.
Maybe the legal state exception based on the state of an object getting corrupted by something.
Right, illegal state exception, that typically occurs as a result of threading issues, I think. There might be various ways it comes about. But yes, if that pops up, well, first of all, that does more likely than not mean there's some sort of programming error, although that would be one of those annoying problems involving multiple threads and synchronization that's really, really painful to fix and to debug because it's only going to happen one time out of 1,000. But yeah, if something like that happens, you might, depending on context, be able to convert it into some other form of application-specific exception. These sorts of questions don't have generic answers, though. It's going to depend on exactly what the code is doing, exactly what the exception means in context. It's a good question, though. It's worth thinking about. And I'm going to be on the lookout for cases where runtime exceptions get converted into checked exceptions. Yes?
I can give a potential scenario.
Okay. Please.
But, for example, Guava.
Right.
Library, you're using although I think it's already not containing, but the cache part, right? The cache loader, something happens, you're not directly coupled, but you want to communicate to the code that, hey, this entry didn't get loaded because of an error. So the only way to do that is with, messing around with the exceptions or whatever. So things may end up getting converted. So it's actually kind of form of communication.
Okay, so you think the Guava cache packages convert runtime exceptions into checked exceptions in order to communicate cache misses?
No. I'm saying, as you
Right,
right? And one of the caches is where you provide a loader.
right.
And let's say something happens,
Mm-hmm.
there could be a situation where you would end up putting in a null or,
Mm-hmm.
it's a read-through cache.
Mhm.
Not knowing what actually,
Right.
and the only way to communicate that is to accept. And you may want to convert a runtime exception
Mm-hmm.
in your code, possibly, if you wrote the loader,
Mm-hmm.
to something that's going to go out to, well, to your other part of the code that is essentially trying to get something from the cache.
Mm.
So, I mean, there are some situations
Okay,
where it
yeah.
can be legitimate.
It does sound like it's an edge condition, but I suspect it does happen. Other questions, comments? We have about 5 minutes. Yes?
Solutions of precautions of people who develop APIs that are used by that way.
Mm-hmm.
If there are certain exceptions, are there any precautions in Iran?
So the question is, if you're developing an API for use by other teams, other people, how do you handle exceptions? Or how do you declare your own exceptions, I guess, is the question. Now, first of all, by API in this context, I assume we're talking about a software library such as Guava. We're not talking about a network service such as the Google Analytics API or, yeah. Right. So you've got a library such as Guava. Depending on what the library is doing, I would generally say declare your own, use the standard exceptions where appropriate. If your API is trying to read a file, and that's what would be expected by the caller of the API, then throwing a file not found exception is the sensible thing to do. If there is an exception that matches what your own library is doing, use it. Sometimes subclass it. Maybe it's config file not found exception, but do use the standard exception types where they fit. That's step one. Step two, for your own exception, if the exception indicates a problem in the caller, somebody invoked your code in an incorrect way that is against the spec as indicated by the Java doc and the API documentation, that would generally be a runtime exception, but document it. Say this method throws this exception as a result of it's a clock constructor and you tried to set the hour to 58. That doesn't, maybe you flip the hours and the minutes. That would be a runtime exception, probably a subclass of a legal argument exception. By contrast, if your method encounters an environmental problem, because it's reading files, maybe it's making network queries, it's trying, in my case with XOM, if I'm reading an XML file and the XML file is malformed, that's not the fault of the caller, that's not the fault of my code in the library, that's the fault of the file itself. And that is a checked exception because it comes from outside the library and outside the caller's own code. And so that should be a checked exception in that case, XML exception in the case of XOM, but whatever makes sense in the context of the specific library you're working on. Okay. Other questions, comments? Yes, in the back.
You mentioned effective Java before. From your experience, where does what you think differ from what effective Java is made of? Let's use exceptions.
Right. How do I differ from Josh Block on the question of exceptions? I agree with about 95% of what is written in effective Java. This is probably often the 5%. And I also don't agree with him on auto value, but that's another talk. I would say, I haven't read lately what he wrote in the third edition. So I'm thinking mostly what was written in the second. So I should, maybe it's gotten better. I did not find it to be actively wrong, but I did not find it to be actively right either. I think he skirts along the edges of this, if I recall, but doesn't quite come out and say it, that checked exceptions are for environmental problems outside your program's control, and runtime exceptions are for bugs. But you can sort of read between the lines and get that. And I think he also, sort of, you can also read between the lines and get that checked exceptions are for problems you can handle and runtime exceptions are for problems you can't. And that's just not true because that is, think about it this way. An array index out of bounds exception, you can handle that if you're expecting it. It's not hard. Illegal argument exception, you can handle it. These are not real problems that stop us, but you probably want to just fix the code instead of putting in a catch block. Yes?
If you have some kind of server API or something, and somebody's making a call, does it make sense to put that into just catch exception so the server doesn't go down?
Oh, so the server doesn't go down. Well, certainly the server, yes, there should be a generic catch block on your request handler if you're using the Java Servlet API or some equivalent. The thing that receives each request should have a big catch block that catches exceptions, but at the same time, there shouldn't be any exceptions at that level. Your code should handle it before it gets there and send an appropriate 404 or whatever error response is appropriate in context.
Sometimes I'm seeing within code reviews, I see people put it and kind of ignores it, but then I get a little squeamish about removing it.
Yeah, I would say a general catch, you never know when, there will be bugs. Runtime exceptions indicate programming errors, but we can't wash out all programming errors. So it is good coding hygiene to have that sort of top-level error handler that says, this is our last resort error handler. Maybe you send to 500 in that case, internal server error. I do see real servers sending that quite a lot these days. Okay, my yellow light has gone on, so I think maybe we have time for one more question, if there's one more. If not, thank you for coming. I'm happy to chat with folks outside in the hall.